Good morning everyone. Today I'm gonna organize a quiz which is of 10 questions and you have 15 minutes. Okay, so this is related to some reactions, some stereochemistry questions and some basics one. So let's start, don't waste your time. So this is a question one, take your time. Okay, I'm gonna zoom this. So this is the question one. You can take a screenshot of this. This is question 2. This one is the third one. This one is fourth. Fifth. Sixth one. This one is 7. This one is 8. I will upload this quiz on my Facebook group as well as on Instagram. This is 9 and this one is the last one. Okay, so you can pause the video, take your time and try yourself. I'm going to answer all these questions. Okay, so look at the very first question. It is talking about which of the following carbon is likely possess tetrahedral geometry. So we all knew tetrahedral means sp3 and sp3 must have 4 sigma bonds. So if you look at this carbon has 2 and then there is a double bond carbon and there is a hydrogen, again carbon, again 2 hydrogen like this and then C double bond O and then here OH. So this is a expandable form of this compound and you can see this carbon, it has 4 sigma bond. So 4 sigma means sp3 and sp3 is called tetrahedral, so it should be C. If you look at the 1, it has 3 sigma bond, so 3 sigma means sp2, and if you look at number 2, again 3 sigma, again sp2, and number 4 also have 3 sigma bond, so again sp2. Clear? sp2 are the planar one, trigonal planar, not tetrahedral. So the 1 is C. Now move to the next one. So which of the following has highest nucleophilicity? So nucleophilicity is what? Nucleophilicity is a tendency to donate electron. It is a tendency to donate electron. If you look at the periodic table, if you are moving left to right, electronegativity increases and nucleophilicity decreases. Okay, there is an inverse relation between electronegativity and nucleophilicity. Why? Because electronegativity is a tendency to hold electron, not to donate, while nucleophilicity is a tendency to donate electron. So you have fluorine here, carbon, oxygen and nitrogen as well, and you can see once you are moving left to right, electronegativity increases here. So nucleophilicity of carbon is highest, makes sense. So CH3 minus will be the right choice. So 2 will be B. Okay, now move to the next. Find out the most stable carbocation. This one is the simplest of this quiz, very easy. So we all knew carbocation's stability depend on tertiary carbocation is the most stable, then secondary carbocation and then primary carbocation. and in the last methyl carbocation, okay. But if any carbocation is in resonance, then that dominates. So resonance is more than secondary, tertiary, secondary, and then primary. So here we don't have a resonance, it's secondary carbocation. This one is secondary, this one is a tertiary, this one is a primary. So tertiary C is the most stable one. So here we can say 3C. Clear? Now the next one is how many chiral center present in cholesterol molecule. So cholesterol and chiral center. So chiral center is what? A carbon have 4 different connectivity. Look at this carbon. This one is bonded with 4 different groups. So this is a chiral carbon, okay. So here we can figure out, listen, this carbon is, I am gonna show with the yellow color. This is not a chiral. Why? Because 2-methyl we have. This carbon is a chiral one, okay, because we have 4 different connectivity. Similarly, this is also a chiral. Clear? 4 different connectivity we have. One is an entire, the chain one in the upper one, and then you have a CH2 group. There is a hydrogen as well, which is different, and this left hand side is a different. So whenever you are going to figure out the chiral center, always look at the entire length. Do not decide at very first position. Suppose my neighboring is CH2, right side neighbor is CH2. So don't say we have same groups. You have to move forward. If again we have CH2, again CH2, then again you have to move forward. It means once you have the very first neighboring atoms are the same one, then move forward. If you got something different, then that can be chiral, okay. Here you can see this is CH2 and this is not, this is just a C. So this is a chiral. This one is also a chiral center because 4 different connectivity. This one is a chiral center. 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 Double bond will never be the chiral. This one is a chiral center. So how many black dots you have except this one? I am going to remove this. So 1, 2, 3, 4, 5, 6, 7 and 8. So we have it. So B is the right choice. So we are in question 4. So question 4 will be B. Now move to the next. This is very interesting question. NABR with DMSO. So NABR is a strong nucleophile. NABR is a strong nucleophile. Why? Because it is bonded with a metal, okay. Na is a metal. So it breaks down into Na plus Br minus. So Br minus is a strong nucleophile. DMSO is a polar aprotic solvent. Its full name is dimethyl sulfoxide. Which structure is like this. Sorry, here we have sulfur. This is DMSO. This is a primary alkyl halide and this is a tertiary alkyl halide. We all knew when we have a strong nucleophile, polar aprotic solvent, then the reaction is SN2, okay, and SN2 is the fastest in the primary alkyl halide, then secondary and then tertiary. Tertiary is the least one, even not SN2 in the tertiary. So the primary one is here, this one, chlorine. So in place of chlorine we have a bromine. Clear? So we have a bromine here. Chlorine remains same. So answer will be A, 5A. 5A. Clear? Now the next question, this is very good question. It is a bit advanced type, okay. So look at here, I am going to teach you some interesting points of this. Here OH on the wedge, here OH on the wedge and here Cl on the wedge. means stereochemistry is same. We all knew SN1 stereochemistry is racemization, and racemization is what? Retention plus inversion, means in enantiomeric mixtures. SN2 is only inversion, okay? But this is not inversion. As you can see, my wedge OH is here, wedge chlorine. So SN2 is not possible. Yeah, SNI is called intramolecular nucleophilic substitution. Intramolecular nucleophilic substitution. And that is my retention. This is retention. So this is only retention here. Retention is what? When the nucleophile attacks in a same side of leaving group. So leaving group on the wedge, nucleophile on the wedge. So this is called retention, and this is SNI. So 6D. I should write with the white. Okay, now move to the next. This is one of the best question of this quiz. Very, very good question. So look at here. We all knew this is a reactant. Let me explain the reaction. This is wedge methyl. Clear? This is wedge methyl. And here you have a methyl. Suppose this methyl is my wedge, suppose. And there is another condition, suppose this methyl is a dash. Now HBr breakdowns into H plus and Br minus. Br is a nucleophile here. The reaction is carried out with the carbocation intermediate. Here you have a carbocation. Can you see? This carbocation is a planar. So nucleophile has possibility of attack. It can be either top, it can be either bottom. So if suppose here you are going to add a nucleophile, so the product will be the dash OH. Dash Br, dash Br. And in this case we have wedge Br. Wedge Br. Clear? So now look at the difference. This is methyl. This is the possible A and B products. Clear? So if you look at this X and Y, this is my X, this is my Y. So X remains same in both products. Clear? These are the two chiral centers we have. So one chiral center has no change, while one has a change. You can see here bromine on the dash, here bromine on the wedge. So whenever such a condition is like that, where one chiral center is fixed and there is just one change with the chiral center, so this kind of relationship is called as diastereomer. Okay. So this is a diastereomer, a pair of diastereomers. Clear? 7C. Make sense? One chiral center has no change, its stereochemistry is same, and there is a change with the one chiral center. So this kind of relationship is a diastereomer. Now this is a very good question from aromatic electrophilic substitution. So let me explain this. Look at here we have a donor group. So donor one are those one which is a lone pair one. So oxygen always has a lone pair, okay. So if I am going to expand the structure, So oxygen is a donor one here. Why? Because of lone pair. So it will donate the electron to this group. So whenever any group is donating the electron to any ring, it means this benzene becomes electron rich. That means more activated ring. It means more reactive, more reactive. So electrophile, this reagent produce NO2 plus as electrophile. So NO2, it will attack on this benzene ring. Why? Because this benzene is more electron rich, more activated ring, and we all knew donor are electron donating groups are ortho para directing, in which para is a major position. So if you are going to decide the para position with respect to this oxygen, so para is this one, so NO2 plus is going to attack at this position. Clear? So here we have NO2. So this is the ortho, that is, and this is the para one. You can see D. Ortho para both can be possible, but para is a major one. So D is the right choice. The left ring is deactivated ring. So A is absolutely wrong. Okay, B is absolutely wrong. So it should be D. So the answer will be D. Now here we have aromatic compounds question. Any compound can be aromatic. It should be cyclic, it should be cyclic conjugated, it should be planar. Look at here, this is cyclic, this is cyclic, cyclic conjugated, planar. Planar means sp2 hybridized. And how many conjugated electron here? 2 pi. So 2 pi means aromatic. I discussed aromatic, anti-aromatic and non-aromatic compounds in a very detailed way. So you should watch that videos. Now look at the B. Yes, 2 pi electrons, so A is my aromatic. Look at B. B have a just 4 pi electron, which means anti-aromatic. Whenever pi electrons are 2, 6, 10 and 14, it will be aromatic. And whenever these numbers are 4, 8, 12 and 16, it will be anti-aromatic. Okay. And here again 4 pi electron, again anti-aromatic. And this one again 2 and 2, 4 pi electron, anti-aromatic. Please watch that video, it will help you a lot. And now the next one is the last. So we all knew NBS is an N-bromosuccinamide. It gives allylic bromination. Allylic bromination. Okay. So let me discuss this in detail. Look at here. This is a ring, this is CH3, this is CH2CH3, and we are using NBS 2 mole. So these are the allylic position, this and this. Allylic is what? sp2 neighbor is sp3, means sp3 carbon adjacent to sp2. So this carbon is sp2 here. Okay, so this is sp3. So the product will be CH2Br. And here we have a bromine. Now the next is we have KCN. KCN is here 1 mole. So it means you have to choose any one bromine, means this is a nucleophilic substitution and you have to eliminate any one bromine, any one. So first of all you should identify what is the nature of KCN. So KCN is a strong nucleophile. Why? K plus Cn minus, so this is the negatively charged. So negative charge are the strong nucleophile, and once the reaction is carried out with a strong nucleophile, it means it should be SN2. Okay, so SN2 means primary alkyl halide. Okay, you have to remove the primary alkyl halide, and I think this CH2Br is a primary one and this is the secondary one. So I think it should be CH2CN. Okay, listen, most of the book saying like benzyl carbocation is a stable carbocation and the reaction is SN1. Clear? That is a very good point. Whenever you have a benzyl carbocation, there is a controversy as well, but whenever benzyl carbocation you have, look at this one, this type of carbocation. This is a stable carbocation. Once we have a stable carbocation, reaction always follow SN1. But this is SN2. So secondary has a tendency to proceed via SN2 and SN1 both, but SN2 is favorable because we have a strong nucleophile. So the correct product according to me, it should be here CN we have. It should be CN here and this CH2Br will be like this. Clear? Because the reaction is SN2. Makes sense? If you are going to remove this bromine, this is primary, yes, but it will form a stable carbocation. So once we have a stable carbocation because of this resonance, so once we have a stable carbocation, then the reaction will be SN1. Okay, so I think it should be the product, yeah, this one, C. C is a correct in question 10. Clear? So this is all about this quiz. So thank you so much. Please share and subscribe. I will do this regularly. Have a great day. Bye.